It's Mr. Thompson's Science Biology. Today we're talking about Punnett squares and types of dominance. So first off, we got to look at the Punnett square and remember how to do it. So we've made the male blue. The male's going to go on top, and the female is going to be red. The female goes on the side. Then you take the top letters and bring them down, and you bring the side letters and bring them across. And that makes your combination. So you can see in the first box, we've got a capital A that's blue from the top. Second box, we've got a capital A that's blue from the top. And we've got a capital A that's red from the side. And we got a lowercase a from the side also. We go to the next column. We've got lowercase a's in blue. And we have a capital A. And we have a lowercase a that are in red that carry across. So that's how we fill in a Punnett square for a simple single cross. So on dominant recessive, you're going to use a capital letter and a lowercase letter. And the capital letter is going to be for the dominant, and the recessive will be the lowercase letter. So if you're using a purple flower as a dominant factor and you have a white flower, then you're going to use capital P for purple, and you're going to use lowercase p for white. So if we cross two that have capital P, lower p with each other, so you have two capital P, lower p, we're crossing them together. Set them up on the top and on the side. So we're going to wind up with one box that has two capital P's. We have two boxes that have a capital P, lowercase p, and we have one box that has two lowercase p's. So the results are that anything with a capital P is going to be the purple. So 3/4 are going to be purple. And then when we have two lowercase p's, that's the only instance where we're going to have the result of white flowers. So just the one box, or 25%, in a dominant recessive will be the white or recessive trait with this combination. Codominance. Codominance is where you're going to wind up with both traits showing up. So both traits are going to be listed with capital letters, and we're going to use blood type as our example. So in blood type, type A and B are codominant. We're not going to deal with O because it's recessive, and we're doing codominance at the moment. So if we take a AB male and we cross with a type B female, then we're going to wind up with two boxes that have AB, and we're going to have two boxes that have B. So we're going to have 50% AB blood type and 50% B blood type. Incomplete dominance is the one where we have some fun. That is because we do blending. So if you have one of each letter, you get whatever the blend is of that. So in our example, we're going to use red flowers and white flowers. And if we have an allele for both red and white, RW or WR, then what you wind up with is pink flowers. So if we cross a red flower with a white flower, we're going to get all pink. If we go ahead and make a different cross, and say we do a pink flower with a pink flower, that's when it gets interesting, because we get 25% that are red, 25% that are white, and we get 50% pink. So you get your colorful garden with your red, white, and pink flowers if you cross the two pink flowers in the situation where you have incomplete dominance. So incomplete dominance is where you're going to find the blend. Next, we have the multiple allele, and this is where you have more than two choices. So most of the time you have two choices. If you're doing multiple allele, then you have more than two choices. So we'll go back to blood type. This time we'll add in the O blood type. A and B are codominant. O is recessive. So if we have an A with an O, we get type A. If we have a B with an O, we get type B. If we have an A and a B, we have type AB. And the only way to get O is to have two O's. So we take a type A male who's carrying an O, and we take a type B female who's carrying an O and cross them. And we have some fun because we get 1 AB, or 25% AB. We get 25% B, we get 25% A, and we get 25% O. So we get all 4 blood types with the one cross. X-linked is also kind of an interesting one. X-linked, if you remember right, the X chromosome, there are 2 of them in females and only 1 of them in males. So in this case, we're going to look at calico cats. Calico cat is codominant for orange and black. So if you have a female that carries the orange and the black allele, you wind up with a calico cat where it has splotches of both orange and black fur. Because the male does not have 2 X's, he has an X and a Y, you're going to wind up with whatever color comes across on that X when you're making the male. So in this example, we're going to take a orange male. The O up here means he's orange. No letter over on the Y because it's X-linked. And then we're going to take a black female. That's what the B's up here on the X's are for. And as we come across the XO, XB, this is calico. There's another calico, XO, XB. So all of the females, all of the XXs, in this case will be the calico cats with orange and black splotches. And then when we look at the male cat, the ones with the Y's here, we're going to have all the male cats will be black. Okay, so we take 1 orange male cat with 1 black female cat. We get 50% calico, or 100% of all the females will be calico. And then we get 50% black male. All the males are going to be black. They cannot be anything else. So this is an example of X-linked, and you do want to use the superscripts on the X chromosome when you're doing this so that you can show that you only have the one allele on the X chromosome for the males. All right. So there's our 50%, 50%. Yes, we talked about that already. And this has been Mr. Thompson's Science Biology, and this lesson has been on using Punnett squares and on the